Welcome dear students. There comes one more question to be discussed on gravitation, and that question was for 4 marks, asked for the study circle, and that question was explain all 3 laws of Kepler's. They are all called Kepler's laws. Okay, so let's discuss one by one with their significance and importance. Kepler's first law, it is also called as law of orbits. Okay, so according to Kepler's first law, all the planets rotate in elliptical orbits around the sun, with the sun situated at one of the foci. Foci is the plural meaning of focus. It is just similar to the center of a circle. There are existing 2 foci, or there are 2 existing 2 different centers. Okay, corresponding to these 2 central points for ellipse. Ellipse is a particular geometrical shape, okay, having a certain particular shape, just like resembling to our normal egg. Okay, then there are 2 positions, as I told you. One is called as perihelion, is the point at which the planet is closest to the sun, and while another is aphelion. There are 2 other names for this, perigee and apogee, right? So perigee is perihelion position, which is the closest or nearest to the sun, and while aphelion is the position at which the planet is farthest from the sun. It is distant from the sun, right? So an ellipse has the property that the total of any planet's distance from 2 foci is always a constant. Okay, a planet's elliptical orbit is responsible for occurrence of seasons. You might be knowing there are 3 seasons. Okay, rainy season, summer seasons, in which you have a beautiful your beloved vacations, right? And rainy season, winter. So all these seasons are because of the elliptical orbits, right? So this is about the law of orbits. This is called first law, or law of orbits. Okay, actually we for calculations use it as a circle, because it becomes then convenient, but actually it is an elliptical, right? So let's move on for the second law. The second law is also called as law of equal areas. Okay, so according to second law, the radius vector extended from the sun to the planet sweeps out equal regions at equal intervals of the times. Okay, it won't be easy to digest unless and until I explain it separately on the another sheet. So let us discuss that. For this, you can consider that suppose you have a roughly drawn ellipse. Okay, and I have one position. There is no central point as such, because for center it is only existing for the circle. You have a center, but for this you have 2 foci, right? So imagine your sun is at this particular position. So this particular position nearest to it is will be, as I told you, right, perihelion, and this point which is now farthest from this position, it is aphelion, right? Now if I draw 2 points and it move from one point to another, say 1 to 2, and if I shade this particular one, don't you find this shaded area, right? And in the same interval of the time, if I consider 2 more points over here like this, what do you observe? You observe another strip, right? I'm going to shade this. Now at the first sight, it don't believable that these 2 areas would be equal, but they are actually equal. Say why? Because when it is closest to the sun for perihelion position or perigee position, the planet will transit very fast. So during a given interval of the time, the area covered in that particular time will be more. At the same time, for the same duration, whenever the planet will move from position 3 to 4, since it is farthest, the force of attraction or gravitation will be weaker this time, so it will move a bit slower. However, the vector or this particular side which is making it to trace the area, it will be exactly same. So in simple words, if I divide this particular area in very small parts and just remove that part and paste using a favicol on this particular area, they will exactly fit. That it means that these 2 areas are equal, and that is the real meaning of Kepler's second law. Okay, so Kepler's second rule may be alternatively phrased as the aerial velocity of a planet spinning around the sun in elliptical orbit remains constant. As I told you, the aerial velocity is always remaining constant. That's why in equal interval of the time the area trace are same. That you mean by aerial velocity constant. So implying that planet's angular momentum remains constant. Right now your standard is not that sufficient enough to understand what you mean by angular momentum, but as you grow in your higher classes, you will come to know what is angular momentum soon, right? Anyways, let's go for the last one. This is the third law, or it is also called as law of periods, and it is the very important law because now it has got a formula associated with it. Okay, it states that the square of the planet's time period of revolution around the sun in an elliptical orbit is precisely equal to the cube of its semi-major axis, or in simple words say the distance from the planet from the sun. Okay, if you are getting confused with the semi-major axis word, then just imagine that it is the distance from the sun from the planet, right? According to Kepler's law of periods, right? So mathematically what we can write is t square is directly proportional to a cube, right? So this particular formula will help you to solve the numericals. The one of such numerical video will going to be coming up next. But to use that particular one, say t square proportional to r cube or a cube, whatever. If I am going to use it for two different subscripts, I will be writing t1 square proportional to r1 cube and t2 square proportional to r2 cube. So if you take the ratio of this, your proportionality constant would going to be getting cancelled, and directly you can use this formula t1 square upon t2 square equal to r1 cube upon r2 cube. And that is very important formula, because if you know 3 of this one, you can find out the remaining fourth one, and these are the commonly asked questions in your exams, right? So this is about the third one. The shorter the planet's orbit around the sun, the shorter the time it takes to complete one revolution. You will surprised to know that it has got a great significance. Imagine that if you are the resident of a Mercury, then your birthday will be in every 123 days. Isn't it very good? You will be enjoying your birthdays every 123 days, right? You will be getting a lot of gifts in a year, right? But if you are on the planet of Pluto, unfortunately, you are going not to enjoy your second holiday in your entire lifetime, because the time period of revolution taken by the Pluto is very, very large. Okay, so that's why it won't complete in 365 days. So you cannot enjoy your birthday getting quickly. So these are the significances, and the climatic conditions also depend on the distance of a planet from the sun, right? So there are a lot of consequences of this laws. Okay, so hopefully you understand this and try to implement cleverly in your exams. Okay, for more such like videos, stay tuned to Study Circle at Europeans Academy. Thank you very much.